In this video, we're going to talk about quadrantal angle. The angle is called a quadrantal angle when the terminal side of an angle theta that is in standard position lies on one of the coordinate axes. So here's some common quadrantal angles. When theta is 0, notice when theta is 0, the initial side and terminal side overlap. And also when theta is 90. When theta is 90, initial side is on the positive x-axis and terminal side lies on the y-axis. Now again, when theta is 0, both the initial and terminal side lie on the positive x-axis. When theta is 180 degree or pi radians, the initial side is on the positive x-axis and the terminal side is on the negative x-axis. And when theta is 270 degree or 3 pi over 2 radians, terminal side lies on the negative y-axis. So these are examples of common quadrantal angles. And as you could see, you could keep going by adding 90 degree or pi over 2 to get other quadrantal angles. So there are infinite number of quadrantal angles. It says find the exact value of each trig function if defined. If not defined, write undefined. So let's try to evaluate sine of negative 180 degree. So where is negative 180 degree? You start from the initial side and you have to go clockwise. So you end up over here. So this is a negative 180 degrees, another example of a quadrantal angle because the terminal side lies on the axis, either x-axis or y-axis. Now let's choose a convenient point that is on the terminal side. How about negative 1, 0? Now you could choose negative 2, 0, negative 3, 0. It doesn't matter, but negative 1, 0 is a commonly used convenient point when the point is on the negative x-axis. So in this case, x equals negative 1 and y equals 0. Now what is r? R is going to be square root of negative 1 squared plus 0 squared, which is going to be 1. Now what is definition of sine negative 180 degree? It's going to be y over r. And what is our y? 0 and r is 1. Therefore 0 over 1 is 0. And we can conclude that sine of negative 180 degree is 0. Now let's try to evaluate tangent of 3 pi over 2. Now you know that 3 pi over 2 is same thing as 270 degree. So if you draw theta that is 270, it's right here. Terminal side is on the negative y-axis. So this is a 270 or 3 pi over 2 is another example of quadrantal angle. Now let's choose a convenient point that is on this terminal side. Let's choose 0, negative 1. Now again, you could choose 0, negative 2, 0, negative 3. It doesn't matter which one you choose, but I like to use 0, negative 1. So x equals 0, y is negative 1. What is r? R is going to be square root of 0 squared plus negative 1 squared, which is going to be 1. So tangent of 3 pi over 2 is going to be y over x. In this case, it's going to be negative 1 over 0. And you know that negative 1 over 0 is undefined since the denominator is 0. So tangent of 3 pi over 2 is undefined. It doesn't exist. Now let's try to evaluate secant of 4 pi. And you know that 4 pi is you get one revolution, that's 2 pi. So you have to go another revolution, and that's 4 pi. So you end up over here. So in this case, terminal psi lies on the positive x-axis. So this is another example of a quadrantal angle. Let's choose a convenient point. I would like to choose 1, 0. Again, you could choose 2, 0, 3, 0, 10, 0. It doesn't matter which point you choose, as long as you choose any point on the terminal side. But 1, 0 is a nice convenience point to use. So what is x? X equals 1, y equals 0. Therefore, r is square root of 1 squared plus 0 squared. You get 1. Now, what is the definition of secant theta? That is going to be r over x. So in this case, it's going to be 1 over 1, which is 1. So therefore, we can conclude that secant of 4 pi is 1.